Have several grad students here as well, so they'll be getting a lecture too. So if you hear comments from the peanut gallery, that's where it's coming from. It will be a fairly small group today, and it's a good topic, but a short one. And so feel free to unmute yourself and ask questions while I go through the slide deck. The first bit is kind of just front matter to make sure everybody knows who we are and what we do, and particularly Idaho Power's program, since Idaho Power is the one sponsoring this lunch. But we are the Integrated Design Lab. We're all about high performance, energy efficient buildings. So buildings that work well for both the people that they house and the environment in which they're built. Grateful to Ken Baker for his mentorship. He's got about 2 weeks left, and then he's going down to part-time, but I'm trying to keep him around as long as possible. We've got Dylan Agnes, who's our daylighting specialist and research scientist, and then we've got several grad students. Lindsay we just lost to GGLO, a great firm, and then we've got Isabel Boycourt, who's not on here yet, but is here in our lab now, and hoping to bring on some new faculty and some new students this fall, since we've got a lot of fun research going on right now. So Idaho Power offers their technical design assistance to anybody that's interested, anybody that's within Idaho Power service territory, which gives you access to free student and research time up to $4,000 worth of our time. So we can do kind of energy models, technical support if you have a question about, say, lighting, whether it's better to replace just LED bulbs versus a full ballast, or lighting temperatures, or looking at some new HVAC technologies, or considering a dedicated outdoor air system, things like that, but you don't have the personal time to invest in that research, send those questions to us. Think of us as just like a free helpline. If you want us super involved from the very beginning of a large project, that'd be a phase 3, in which case Idaho Power covers 75% of that cost, so it's a pretty good deal. Plus, we're academics and grad students, so we're pretty cheap. Yeah, it's a great program that's available. So you can find more information on our website, or just email us anytime if you have a question. We've also got our building simulation users group. So today I'm talking all about ASHRAE Standard 209, which is energy simulation aided design. And we've got a full working group that's just focused on this particular topic. So coming up in August 25th, it's looking at 2D heat transfer. In September, we're looking at luminaire level lighting controls and how to incorporate that into energy models. So if you are just on the journey, just starting out on energy modeling, or even just vaguely interested in energy efficiency, these are great topics and great talks that are once again free, and prizes are awarded even to virtual attendees as long as you're in Idaho Power service territory. So another resource out there. We've also got our Energy Resource Library, ERL. So you don't have to be a mechanical geek to use these tools. If you just have any problem with a building, you can use these to diagnose that issue, and we can help train you on how to use the tools. We've got some user guides, got some new Vuzix glasses, so you can do a virtual walkthrough, so you don't have to be at the building site itself, but you can give it to somebody who's already there, which might save on travel costs and things like that to do a remote energy audit. Thermal cameras, light meters, about 1,000 different tools, even some monitoring indoor air quality and ozone concentrations, which are a big deal during COVID eras. So just be aware that that is a great resource to you. And then Idaho Power has their commercial and industrial energy efficiency program. So a variety of different programs available to customers. Even if you're just renovating from a warehouse over into a brewery or something like that, and you're looking at ways to reduce the load, there are a lot of incentives out there, particularly to reduce summer peak. and there are some free energy saving kits to businesses. So check out their website, idahopower.com/business. And then they've got some new incentives that rolled out yesterday. So check out their website. We can put you in touch with, ASHRAE Wilhite, who oversees this program. They are currently running a doubled professional assistance incentive. I believe that's still the case. I know it was doubled this spring. I don't know if that's still true after June 15th. But they'll put dollars toward projects for your time to really invest in additional efficiency measures. That's separate than their technical design assistance program. So just be aware that there's some great programs out there. All right, so we can kind of dive into the heart of the topic today, which is energy simulation aided design for buildings, specifically on ASHRAE standard 209. I'm gonna have to move my camera around a little bit. I'll leave some time at the end, but as I said, feel free to unmute yourself and ask a question at any time. Feel free to interrupt. This talk is really targeted at professionals who are just starting to incorporate energy modeling into their architecture or engineering practice. For kind of pros who already do this, I hope to provide some additional references and resources that can help kind of hone your craft. I'd also point out Tim Johnson's BSUG last year on energy modeling for code compliance. You can find that on our YouTube channel, which kind of walks through this with some really cool kayaking references and some good metaphors in there on how Cushing-Terrell uses some of these principles in their particular practice. But I want to just go over kind of what is Standard 209, what's covered in it, do you need it? Is it good for anything? Is it just one more piece of red tape? I'm a big fan of it. So this is an actual standard that you can purchase. We have it available in our energy resource library if you want to check it out. It's fairly brief if you look at it. I've been able to read through it several times, and it's kind of providing boundaries. That the goal of it is to really define in detail and to facilitate the modeling process so you are maximizing its impact. Too often, energy modeling can be kind of an after-the-fact scorecard for certain types of certifications. And this standard is really pushing for energy modeling to have a greater impact on the design. So there's some general requirements of what does good energy modeling look like, and then the specific modeling cycles that can be incorporated. Not that must be, but should be, I would say. Within the design phase, where most of the modeling is occurring, but also some construction and operation features you can model, and then some post-occupancy assessments, and where to find additional resources to do the best you can and get some really good quality assurance and quality control on the energy modeling that you're doing within your firm. So starting out with, okay, what's required to do an energy model? At the very least, you need to use an energy modeling program, and one that is compliant with another ASHRAE standard, ASHRAE 90.1 Appendix G, which lists some different software out there, but mainly it's programs that can run every hour of the year, 8,760 hours per year, and also includes things like thermal mass effects, part load curves, things like that. If you want an actual list of the programs, there's a link that I put here, so you don't have to look for a standard nested within a standard, if you will. And these slides will also be posted with this recording on our YouTube site. So first things first, you need the right software. And anytime somebody's doing energy modeling, most of that is based around this ASHRAE 90.1 Appendix G, whether that's for LEED, whether that's for tax incentives, things like that. That's a great standard for what the energy model should actually look like, whereas ASHRAE Standard 209 is focused on the modeling process itself. So that gets into the next point, which is who should be doing this? And ideally, it is a certified individual. And that might be either a BEMP or a BISA, which is a Building Energy Modeling Professional. That's a designation that ASHRAE administers. There's also the Building Energy Simulation Analyst certification. And that certification is provided through the Association of Energy Engineers, AEE. As far as I can tell, there are only 2 certified modelers in Idaho, and both of them are heavily involved in BSUG and give plenty of lectures and are very generous with their time and sharing with the community. So I would seek them out. You can find them on the ASHRAE website by looking for certified professionals for BEMP. I won't mention them by name in case they watch this and I embarrass them, but they're both fantastic individuals and I'd highly recommend reaching out to them. The other kind of general requirement of this ASHRAE Standard 209 as you're just getting started is when you're starting this process, what are you trying to get out of it? And usually, this is for a client. The owner of the project really should know specifically what's going into the model and what's coming out of it. So within the standard, there's a table in the appendix that provides kind of an outline of sample kind of requirements that an owner ideally might see coming out of it as they're contracting your firm to do some energy modeling. And this is everything regarding overall EUI, energy use intensity, of what this building should look like in the future, down to making sure you're meeting minimum code requirements for the different walls and envelope, the type of HVAC that you're putting in there. Because what we want to do is set a target, develop a roadmap so we can figure out where we're starting and where we're heading to throughout the whole modeling process. A lot of this standard is just about getting interested parties involved and talking to each other. I know architects and engineers and owners and contractors aren't always on the friendliest terms, but that's kind of our tagline, right? The Integrated Design Lab is trying to integrate that design process, so we're bringing all parties into the room, whether that be the owner, the lead consultant, the energy modeler, sometimes the contractor, so that there can be very clear communication on what's required for the model and what's required to make the next design decision, so that you can really get some good quality assurance within the team and have the whole team review next steps to look at the model and spark some different ideas. So starting out, what do those discussions revolve around? Initially, it's just the climate and site analysis, making sure that everybody knows that, this building's in Phoenix, Arizona, so we're really worried about cooling and maybe water consumption, as opposed to Juneau, Alaska, where we are going to try and maximize all the internal gains and hyper insulate our envelope to reflect heat back within. So there's tools out there like, Climate Consultant, Energy Star is energystar.gov. Their portfolio manager is a great way to identify other buildings in the same climate and what their energy use looks like, so you can start benchmarking, setting some targets, setting some goals. And once you come up with like a reasonable idea of, okay, where are we heading? What do typical buildings look like? Where do we want to be? That's when you can start having an informed conversation with all the parties in the room and do your first energy charrette, where you're looking at the trade-offs of different building configurations and what the owner is really trying to get out of it in terms of life cycle cost assessment. Like, are they willing to look at a 5-year payback? Is this client going to be there, you know, in that same site for the life of the building? So we could be ambitious and look at maybe a 20-year payback or something like that. That will really help define the scope of the modeling and how ambitious you can actually be. Then you can begin looking at the specific data that you will need to both put into the model in terms of, you know, square footage, and then what you want to get out of the model, whether you're trying to minimize, say, the heating or the cooling load. In terms of the modeling cycles themselves, they fall into 3 categories. So initially it's just, you know, having those conversations, and then we dive down into, okay, let's start working on an initial energy model. So it can be this iterative process. There's the design cycles, there's some construction cycles that can happen as the design documents are being developed. And then afterwards, there's the post-occupancy modeling. Within ASHRAE Standard 209, they require at least 3 modeling cycles. That could be 1, 4, and 11. That could be 2, 4, and 8. At least 3 different cycles. You can choose kind of from this menu of different options, and I'll dive into them here in a minute. But one that's essential is the load reduction modeling cycle, so that you are really focused on reducing the energy consumption that's going to be at the site. So looking at the first one is often referred to as a shoebox model or a simple box model. And this is figuring out kind of general end use characteristics before you're even setting up the actual geometry and orientation. So this could literally be a box. I thought that would be a bit boring to put on this slide. I was going to have this very dynamic, you know, slideshow, but then I had a white background and a white shirt, and I was a floating head, and it was just too weird. Well, we'll try that on a future one. But it doesn't have to be this boring shoebox, right? You can add some details to it, and I would really encourage you to look at the Pacific Northwest National Lab prototype models. There's measures within OpenStudio to generate these. You can also export them as Energy Plus IDFs, different programs out there, and then import them into, say, you know, Autodesk programs or things like that, so that you get like, okay, here's what a generic hospital might look like. This is the generic small hospital model that exists within those prototype models, or a generic school. From that, you can figure out general schedules, where the major energy use might be in your particular climate. And then as you know, start looking at some of those outputs, maybe reviewing some things like Energy Star's Portfolio Manager or the CBEX database, you can start moving into the conceptual design, saying, hey, we know that one of the major drivers here is going to be summer electricity consumption. That's where the major cost is, and there's going to be a lot of cooling. So now, while the form is still subject to change, you can figure out how to do something about those loads that you saw in that shoebox model. Here's an example of one that we did in our lab, where they were considering 2 different ways of adding a 3rd floor to a site, and they wanted to maximize the self-shading within the building to minimize the amount of cooling that was required during the summer. I think one of the most effective uses I've seen internally that our lab has done was when we worked on the Center for Advanced Energy Studies building up in Idaho Falls. And during the design charrettes, you know, it was still flexible enough that we could change the orientation of the building. And I don't know if you spent much time in Idaho Falls, but it's a windy place and it's pretty chilly during the winter time. And so instead of having originally the entrance planned where they thought, which I believe was on the west side, they realized that that was just going to get, you know, buffeted by wind all winter long. So anytime somebody opened a door, you'd get this like awful gust, you know, right through there, you know, like a Ebenezer Scrooge visit from one of his unfriendly ghosts, right? And snowflakes blowing in, and you didn't want that. So they actually changed where the entrance was on that building. And that's a major concession for an architect to change the whole approach to the building, but it makes for a much more pleasant experience walking into that site. I can testify personally. Even if the building itself looks like normally the entrance would be over here, instead they put it on the north side. So you walk in and it's much more sheltered from the wind that was coming off of the canal near there. So that would be an example of what happens during the conceptual design phase. So you start with that box, you found out where the major drivers of that climate and site might be, and then you start to adjust your form based on that. The next is diving down a little bit more. So now, you know, the geometry might be a little more locked in at this point. The clients had some feedback on some of the building forms and you might have had to compromise. So now you've got a little bit of that envelope or geometry around, and you want to minimize the amount of energy use within those boundaries. So our scope is getting kind of smaller and smaller. This is the one cycle that is required for compliance with ASHRAE standard 209. So to make sure that you are actually looking at loads and working on the design to reduce them as much as possible. This graphic, you probably can't read, it's tiny type, but this was from all the hours and temperatures in McCall, Idaho, over the course of a typical year. And it forms kind of a bell curve. And you want that building's balance point temperature when it switches from heating to cooling to be as close to this middle point as possible. And up in McCall, surprisingly enough, about half the hours there each year are colder than 30 degrees. And that might be just like a, you know, study of the blindingly obvious for anybody that spent time in McCall, but maybe you're working on a new site, you're less familiar with that climate. So you start looking at that and it might reveal some things that you might not first guess about what you should really be targeting in terms of envelope and building consumption, so that you can say, you know, this is really going to be a cooling driven, or in McCall's case, a heating driven building. So the more that we can insulate this building from its surrounding environment and bring in, say, passive solar during the winter, even though we might pay a penalty for overheating it a little bit during the summer, most of our hours are going to be pretty chilly, and that's going to be the major driver of our energy costs each year. And if you're not familiar with that particular climate, or even if you are, I think it's worth asking people out there who have experience in that area, who have done this type of design and have a proven track record of good buildings that people are happy in, that have low energy bills. And people are proud of their work, right? They'd love to share it. I know for me, I'm still a young engineer. I can present, you know, the things that I've read, but I'm really standing on the shoulders of others that have been out in the field for a long time, that can come back with not only anecdotal, but also data-driven research that that they'd love to share and see more buildings kind of adopt, so that we kind of live in a more comfortable and more efficient world. So reach out, even if they might be competitive, to see if they'd be willing to, you know, sit down for a drink and share some of their lessons learned. You know, maybe insulating the slab might be overkill in this particular environment, or it ended up saving this other building, you know, tons of energy, which you won't know until, you know, you've kind of spent your time in the field. After you've kind of reduced your loads and kind of come up with some ideas, now is the time to look at HVAC selections, and not before load reduction, but afterwards. Because as soon as you start sizing a large HVAC system, and then you say, oh, actually, we can reduce our heating loads by doing X, Y, and Z. Well, all of a sudden, that's going to change all your options, and you'll have to go back to the drawing board. And engineers don't like kind of looping back around and redoing things that they've already thought about. So this is the modeling cycle number 4, where you really get to examine the impacts of different HVAC systems. And this is that integrated design process. You know, for example, radiant buildings, buildings that use radiant heat for 50% or more of their heating or cooling needs, can be very, very efficient. And I think more than half of buildings that have been built since 2012 that are targeting net zero use radiant systems. And I'm a huge fan of these systems, but they have very limited capacities depending on how they're installed and the type of building. And if you have tons of southern facing windows or a really hot environment, this system will not have the cooling capacity needed to keep occupants comfortable. And it will just lead to headaches down the road. But it's going to be fantastic if the building loads do kind of meet within those threshold of, say, 36 BTUs per square foot per hour. If you can minimize your heating loads to that, then it's going to be a great system, and it can take care of your building 99% of the year, which is wonderful, and you won't have to rely on an expensive backup system. Whereas if your building loads, your heating loads are, say, 50 BTUs per square foot, at that point, you know that you're going to need another system, and having those two systems might just add too much complexity, too much capital costs, and you have to say, okay, well, radiant is great, we can't do it in this instance. But you're not going to know that until you go through this modeling cycle. So as you kind of figure out some of those different HVAC types, now you can kind of move into design refinement. And so this is really supporting the architects and the design as it moves forward, but before construction documents are finalized. So this is a time to look at things like daylighting pattern guides, and you might say, okay, we know that we need shading on the southwest side of this building, but how far should those overhangs be? How can we maximize the amount of light in the space without getting direct solar glare? This is kind of part of that design refinement. It kind of blends in a little bit to the integration and optimization step. So it's just making sure all the systems are really synced up and there's good communication amongst the team of how the building is supposed to function. And this is where you're really figuring out the why of the design, so that you don't end up with those like random features. There's a site here in Boise. It is not long for this world, so I feel okay saying this. But you can drive down 6th Street and there is a building which has some bars out front that were supposed to act as shading devices. But they're bars, they're not fins, and there's no angle to them. So the sunlight comes right through. And it creates kind of an odd pattern for the interior, and it doesn't actually shade much of the building. Now, I believe, I could be mistaken on this, but I believe it was initially thought that there could be some vines, some greenery, some landscape design that would grow up and fill out these ledges, if you will, so that they'd be shaded during the summer, and then when the leaves fall off of the vines during the wintertime, you are bringing that sun in. Beautiful, beautiful idea. And yet somehow between that initial idea and the execution on the site, maybe there wasn't enough space to add in the planters for the vines. Maybe they were too high up, or they worried about the water impacting the brick over time with all that watering. For whatever reason, the vines never happened, and so you just end up with these rather expensive, interesting looking shelves outside that do not do anyone any good. And that's where design cycle number 6 is really targeted at, so that there is that alignment between building design and intent and execution. So everybody's talking in the same room at the same time, so you don't have the architect thinking, we really need to minimize these south-facing windows, this corner, it's getting way too hot in the end and there, and the engineer is saying, actually, we really want that because that allows us to downsize other parts of the system because we can recycle that heat somewhere else, right? Once again, it comes down to integration, getting people in the same room, so you can really hash it out. COVID has made a lot of this virtual, which can be hard because we can't always see facial expressions as well. People keep themselves on mute, and you don't get those little ahas or ums, you know, those little sounds in there that might show assent or dissent. It's harder to communicate, but we can do it, right? And it does allow more people to collaborate quickly without the travel time. So use it to its fullest advantage, and just once tell people to make their voices heard, especially those that are quieter. Maybe these are the engineers that are used to just like sitting in the back and just waiting for the architect to finish up, and then, okay, we'll take that design and go with it. Instead of voicing their opinion of saying, hey, we tried VRF systems here and it was really challenging. We'd recommend maybe using some mini splits in a building of this size, or something of that sort, so that you're just coming at it with a bunch of different perspectives. Even if it's just an hour, and it might be a frustrating hour, hopefully it can kind of generate some more of that integration and optimization for that design. And the last design cycle step is value engineering, which is where all our good ideas go to die, right? Hopefully not, I'm kidding, mostly. But with the huge rise in construction costs, there's usually a lot sacrificed. We saw that happen on a recent project here where they had very ambitious energy goals, and yet due to the scarcity of materials and the actual budget that they got back from the contractor, it looked like it was going to be really challenging to meet those goals. It doesn't have to just cut off all sustainability features, though. And I think this is where energy modeling can have a great impact in terms of the actual life cycle cost assessment. So the energy modeling can keep a holistic view, so we don't lose out on those combined efficiency savings things where we say, okay, we love this insulation, but really it's a little too expensive, so let's cut down on the depth a little bit. You might save some there, but if you're not talking to the engineer, that might mean larger HVAC equipment, which means larger ducts, which means larger fans and larger energy expenses, and maybe some more building controls than you initially intended. That can spiral, and you end up spending more money than you would have otherwise, keeping in those combined efficiencies. And I love that. It doesn't happen every time. Sometimes there are extra green premiums, if you will, of design features that might have to go during this phase. But I'd urge you to keep the energy model in this process so you can maintain that long-term view, and that the client is aware of whatever they might be giving up through the value engineering process. All right. The last set of modeling cycles while the building is being constructed, I'll cover a little more briefly, but these are happening kind of during the construction. So modeling is done after the construction documents are complete, but before actual construction, and that would be step number 8. So that's where you're looking back at your original goals, and you said, okay, after value engineering, after everything like that, here are our design documents, here's our actual energy model as we've completed the design. Are we doing okay? Are we still meeting that initial target, right? The big driver of this process is making sure we've got a clear roadmap and we are meeting that goal. So do a check during the as design process, and then start incorporating change orders. Maybe there's feedback that this window couldn't be sized in this particular way or manufactured that way, so a change order comes in. How is that going to affect the energy performance? So continue to incorporate some of those change orders in the energy model so you can see overall, is that going to affect my LEED points? Is that going to affect my certification for the Living Building Challenge? Things like that. And then at the end, of course, after construction is complete, then you can compare the as-built energy model to the original design. And that as-built energy model performance is hopefully fairly accurate of what will actually be there. But one of the most important cycles that I think gets left off far too often is, okay, the building is up and going. How did we actually do? Was our energy model good enough? And that's where this cycle number 11 comes in, post-occupancy. And this must occur at a minimum of 1 year after the construction and occupancy of the building, so that you have a full 12 months worth of utility bills. At this point, you're going to transition the weather file that you have been using, which was like a typical for the site, into an actual meteorological year, the actual weather file that occurred over that time. There is, once again, another ASHRAE guideline. ASHRAE, if nothing else, does a lot of guidelines, but I find them to be very helpful. Guideline 14 is pretty short, and it's all about calibration of energy models, so that we're not saying, hey, look, we did this energy model. The building should be doing this. Trust us, right? This is a check, and there are 2 different metrics. I apologize for the acronyms. It is the coefficient of variance root mean square error, that's CVRMSE, and that must be within a certain range. So that's kind of like looking at the scatter of predicted versus actual consumption and making sure that scatter's fairly small. And then there's the mean bias error, so making sure that scatter's small and that the center of that performance over the 12 months, or even if you're doing the hour by hour, is in the right level. So you're not massively over predicting or under predicting performance by within 10%. I just gave a previous BSUG talk on weather normalization, which provides some resources for how to get those weather files and how to do some of that calibration. There's a lot of other resources out there that are available, some of which are laid out within the standard, within the appendix. And I find them to be very helpful as just overall checklists in terms of quality assurance, making sure that we're incorporating the right information in, so we don't do the, garbage in, garbage out. That's not the energy modeling we want to do. We want to make sure we've got good inputs and good outputs. So there's also a model output checklist that includes detailed metrics on everything from the building level, as well as the system level, and even like the plant level loads. So where can you find some more standard checklists aside from just what's in this appendix? U.S. Green Building Council, I think they did a contract with 7 Group, has some templates which are really nice. Sarah Architects, Rocky Mountain Institute, a ton of free resources out there from Rocky Mountain Institute. Highly recommend. ComNet is out there, as well as templates for the actual reports and what those should look like. There's a book out there which you can download, once again, out of the Rocky Mountain Institute, and that is by James Waltz, who authored Computerized Building Energy Simulation Handbook. Like I said, it's a free resource. Check it out. IBIPSA is a great and growing organization, and they've got a building energy model library out there, which includes some kind of report templates and checklists. So you're not the only one, and there's a great community out there if you decide to get into this energy simulation aided design. I would like to thank Jason Glazer, who has chaired this committee. There's also a very good ASHRAE article. This came out in the December 2019 issue. So this is a fairly recent standard. It was under development for 7 years, but didn't come out until 2018. But there's an article that kind of walks through each of the steps in a little bit more detail, if you'd prefer to read over that. And I just love to see energy modeling used more and used better, right? This is an ideal process. I will fully admit that our lab right now is engaged in a couple of energy modeling projects, and we're just a little late on this. We can't incorporate all the things that we would love to. But this standard really lays out our ideal model of how we would like to approach a project. And even if we can't meet it for each project, it's a wonderful aspiration. And I think this will just improve the value of energy modeling going through this process, and make it more and more useful, so that it gains in value and grows in value, so that more architects and engineers use it over time. So with that, I'll stop talking, and open it up to any comments or questions. And Kelsey, I'll leave it to you as well to launch a poll, which Idaho Power appreciates, so you can tell us how we did. Thought I had a glass of water, but I didn't, so just wait on that.
I had a question for you, David.
Yeah, question from the grad student audience. Yeah.
Okay. So you mentioned that there's only 2 ASHRAE building energy modeling professionals in Idaho. What can you comment about like the current state of a building energy model or in Idaho, and like the prospects that you expect that field to grow into?
So the question, in case the mic didn't pick that up, is on the simulation community within Idaho and certification and the future prospects for that. Idaho has a surprisingly strong energy modeling community. We've got a surprisingly high concentration of engineers and architects within Boise in particular that do projects all over the country. BEMP as a certification is fairly new, as is the standard. Yeah, I see it growing, perhaps not exponentially, but significantly over the coming years, especially with this new standard out there and the encouragement from people to really have that certification by their name. The last thing you want is to say, hey, we did energy modeling for this building, and then the owner looks at their energy bills and it's terrible, right? That certification, one, is helpful in terms of providing the client some peace of mind, and it also just provides some quality assurance as well on the people that are doing it, and leads to some more confidence. Yeah, the 2 guys that are certified here, they're doing energy models every single day, and are great. Given the new administration and politics and the growth towards LEED version 4, really focused on not just doing an energy model for model's sake, but making sure that building performance is actually, it's pretty tough. They're really pushing for high quality energy models that are showing proven performance for those buildings in terms of final energy consumption. And as more and more people are starting to use that, I think there would be more and more of a demand for people with that certification.
Thank you.
Yeah. We've got a lot of engineers and architects here that do projects all over because standard of living here is great. Cost of living used to be a lot lower than it is now, but everybody wants to be in Boise now, which is great. But that's one of the reasons. If you look up the ASHRAE certified professionals in California, though, it's like a many-page list of people there. All right.
And I guess I have another question on that.
Yeah.
How, given that this is an idealized process, how much do you see companies and firms actually like going through all these different steps rather than kind of skipping over maybe some of the earlier designs and
Yeah, I know that not every project gets this treatment. And each firm has their own workflow. I find this very, very valuable for setting up that workflow that each firm on their own can customize. And I know of the firms locally that do good energy modeling, they do follow this workflow as closely as they possibly can. You know, not only for their own reputations, but also just because it enhances their product. All right. Well, with that, I'll go ahead and stop sharing and appreciate folks that have been on and anybody that might be watching the recording of this. Apologies for last time with our technical snafu. We set up some guardrails in place for the future so that shouldn't happen again. But appreciate your time today. All right, thank you.
Excuse me, is my microphone working?
It is, yeah. Thanks, Larry.
Oh, okay. I'm a close follower of ASHRAE 90.1 over the many years, and I know they update every 3 years on 90.1. And I notice also that this is the 3rd year for the latest version of 209. Do you know if it's also updated every 3 years?
I don't know if 209 is updated every 3 years. One thing that has changed with LEED in regard to 90.1 cycles is now instead of going modeling in accordance with 90.1 Appendix G 2013 or 2016, it's all benchmarked at that 2010 level for your baseline building construction standard. That makes it easier to standardize energy models. And now there is a multiplier, like a performance. You have to do X percentage better than your baseline building, which is different depending on the building type. So schools have a certain percentage, they have to be better than that 2010 standard. Offices are at a different level, and that can be pretty tough to achieve. So while it might seem counterintuitive to lock in things on an older 90.1 cycle at that 2010, it does make it easier for firms to develop their own scripts and things like that to generate those baseline models for comparison, particularly in regard to LEED. How that gets updated over time, I think there's some growing pains right now, and it's a learning process. So some of those percentages might change. I hope to see this standard become more widely accepted and also expanded. This is a great kind of bare bones approach, and I'd love to see kind of more details, more resources added into this, and I hope that the committee will pursue that.